So let's start looking at this first one. It says the perimeter of a square. Now first things first, if I'm thinking about a square, a shape that's kind of like this, then automatically I should be thinking about the area being base times height. But in a square it's even cooler because it's not just base times height, it'd be like the base squared, one of the sides squared. So that's what it's saying right here, the area is side squared, and if the area is 36, then that means each of these sides was 6. And if each side is 6, that means the other two sides are 6. You add them all up, you get 24. So that's how they're getting that piece there. Similarly, when we talk about this one where it says the area of a triangle using the Pythagorean theorem, well, we noticed that the hypotenuse is 17 and one of the legs is 8. So I got to figure out how to get the third side, and that's what they do here. They set up a Pythagorean theorem looking for this third side, and they realized that b squared is 225. So then if they take the square root, we get 15. So b right here, this equals 15. And then go back and ask yourself, what was the question? The question was, what's the area? Well, area of a triangle is 1/2 base times height. We know that our base is 15, our height is 8, so we get 60, because half of 8 is 4 times 15 is 60. This last example here, I'm going to go through this one a little bit slower. It says the area of a rhombus. A rhombus is a kite, and the area of kite is just 1/2 times the diagonals. The diagonals multiplied together. So I know that the area is 6x cubed y cubed, and it tells me that one of the diagonals is 4x squared y. So I'm going to plug those two pieces in. What they don't show you is this in between here. I'm going to help you with that a little bit more simplifying, just so we can see exactly what's happening. So I know the area is 6x cubed y cubed, and over here I have 1/2, and then this is 4x squared y, and then the second diagonal. Well, the 4 and the 2 are going to reduce. So the first thing that I'm looking at is that 4 and that 2 become 2 over 1. And then what I want to do is get rid of this x squared y and the 2 by dividing both of those on each side. I notice that 6 over 2 becomes 3. X cubed over x is just x to the first. Y cubed over y is y squared. Once I have that solved, that tells me what my second diagonal is. These are just the setup. These are kind of examples to show us what to do. Now I'm going to work through a few examples from the very beginning all the way through to the end. So let's start. The first one, it says find each measurement. The area of a square in which the perimeter is 36. Well, again, let's draw ourselves a picture so we know what we're looking at. If I have a square, oops, want that to go back. If I have a square, and I know that the perimeter is 36, what that's telling me is that all the way around is 36. Well, I know that if I called this B, well then that would be also a B and a B and a B. And I know that if all 4 sides are going to give me the perimeter, that's just 4 times B. So I have B plus B plus B plus B. I've got 4 of them. I'm going to divide by 4, figure out what B is on each side. And I figure out that 9 is one side. So B equals 9. But it's asking me what's the area. And the area, if this is 9 and this is 9, it's going to be 36. Oh, whoops. Pardon me, it's not 36. I was thinking with the perimeters. The area is equal to b squared, or one of the sides squared, which in this case is 9 times 9, or 81. Now the last key thing is our units. We start out with inches, which means that if we're doing area, we're going to end with inches squared, because it's inches times inches as well. Now a lot of times you'll see this written as square inches out in words, but it's the same thing. Same exact thing. The perimeter of a rectangle. We notice that in this rectangle, you see that the base is 4, So that means this other base across from it's 4. And the area is 28 centimeters squared. So I know that it's 28 centimeters squared for the area. I got to figure out what this is. Well, I know that area equals base times height. So 28 equals 4 times h. If we divide by 4, we figure out that 28 divided by 4 is our height. Well, that's just 7. 7 equals our height. Well, I know that this side is 7 and this side is 7. To figure out the perimeter, that's all 4 sides added together. So the perimeter is going to be 4 plus 4 plus 7 plus 7. That's 14 plus 8, which is 22. Then I look at my units. It was centimeters squared for the area, so that means it's just centimeters for the total lengths. Again, if you need any part of this slowed down, just take a second, pause it, come on back to it. But I'm going to keep on moving. This next one, it's asked me the height of a triangle in which the area is 6x cubed y and b is 4xy. Well, let's start with the triangle first. Just going to draw any general triangle here. It doesn't really matter exactly what it is. What does matter is the height and the base are perpendicular. That's the only thing that really does matter. Close enough for now. So I know that the area of a triangle is half the base times the height. I'm just going to come back to these formulas. We always got to come back to those. We got to know what those are. So the area is 6x cubed y. So 6x cubed y is my area. Then I have 1/2 times the base, which in this case is 4xy inches. And then we have the height, which I don't know what that is. Well, let's start reducing and seeing what we come up with. If I reduce the 4 and the 2, I get 2 on top, 1 on bottom. So I'm going to divide by 2xy. That'll make this a 1. And then let's see what happens to the other side, 2xy. Well, the 6 and the 2 are going to become a 3. X cubed and x is going to become x squared. So I have 3x squared. And y over y is just 1. So 3x squared is all that I have left on the left side. And on the right side, I have an h. So that's my height. So this right here would have been 3x squared. Now if I wanted to check my answer, here's what I could also do. Knowing that the base is 4xy and the height is 3x squared, I would see that the area equals 1/2 the base times the height. And the base is 4xy, the height is 3x squared. So I take half of 4, that's 2. 2 times 3 is 6. X times x squared is x cubed, and the y times 1 is just 1. Hey, that's my area. So I'm good. Now the only thing that I didn't really write in here, but still just as important, is that this is inches. 3x squared inches. Let's do this next one. Let's do it in a different color, just to differentiate a little bit here. Keep your eyes fresh. We know that the area is 48xy feet squared. Ooh, well that's interesting because I see that this is one of my bases. Here's another base. It doesn't really matter which one is which because it could be upside down for all we know. The only piece that we don't know is the height. That's what it's asking us to find. Well, the area of a trapezoid, that's 1/2 the sum of the bases times the height. So let's fill in what we know and then work our way from there. I know that the area is 48xy. I know that the bases are 3xy plus 9xy. Then I have an h here. Well, since these are like terms, because they have the same variables, so the same powers, then I can put those together. I got 12xy times 1/2 times h, and then 48xy over here. Let's reduce this a little bit. The 1/2 and the 12 is now 6 over 1. So I have 6xy times my height equals 48xy. When I reduce down to 1 to get that h by itself, These x's and y's reduce down to 1. The 48 and the 6 becomes 8. So 8 equals h. What am I missing? Units. It's 8 feet. There we go. Let's keep working. Remember, pause if you need to. Otherwise, let's keep moving. Okay, let's change colors again. How about brown? The area of a rhombus. Ooh, let's try and draw ourselves a rhombus here. Doesn't have to be exact, but just to give us an idea of what we're looking at. It kind of looks like a rhombus. The way that I would know that it's a rhombus is that all 4 sides would be the same. So I'm going to mark them like that just so we know what we're talking about here. All 4 sides would be the same. It says diagonal 1 is 21 yards and diagonal 2 is 24 yards. Oh, this is a lot easier than I would think. Because when I hear the word rhombus, I think kite. It's just a kite. It's a perfect kite because it's symmetrical, horizontal, and vertical. But it's just a kite. And the area of a kite is equal to 1/2 the product of the diagonals if we multiply diagonal 1 times diagonal 2. So all I gotta do is plug in the pieces I need. I have 24 and 21. It doesn't really matter what order they go in. Half of 24 is really going to be 12 over 1. And then 12 times 21 is going to be our area. So if I were to multiply 12 times 21, we got 2, 4, 21, 2, 5, 2. So the area is equal to 252. That's my units. Well, they're yards, and because I'm doing area, it's yards squared. Okay, this one's a little more complicated, but notice the information that they give us. They're asking us for a diagonal. D2 equals what? I don't know yet. It's a rhombus, so it's the same formula that we started with before, but we just got to fill in the information we know and find out that which we don't. So I know that the area is equal to 1/2 diagonal 1 times diagonal 2. Now I'm going to put in the pieces that I do know. I know that the area is 630 x to the 3rd power y to the 7th. Now over here I have 1/2. The diagonal is 30 x to the 2nd power y to the 3rd times diagonal 2. I want to get that diagonal 2 all by itself. So let's reduce and get that diagonal all by itself. We got 15 over 1 for the fraction, 1/2 and 30. Then I'm going to divide this side by 15x squared y to the 3rd power. That's going to make all these reduce down to 1. Because this is algebra that I'm doing here, and I have to do the same thing to both sides, I divide this side by 30 as well. 15x to the 2nd power, and then y to the 3rd. Now that I look at it, I have 630 over 15. How many times is 15 going to 630? Well, let's figure that out. 15 goes into 60 4 times, and that's going to give me 30 left over, which is going to be 2. So this is really 42 over 1. The x squared and the x cubed reduce to just 1x on the on the top. The y cubed and the y7th reduce to just y to the 4th on top. Now to clean that up, that means that we have 42 x to the 1st, y to the 4th on this side. On the right side, everything reduced except diagonal 2. Hey, look at that. We got the piece that we wanted. So the second diagonal is 42x to the 1st, y to the 4th, inches, because we're using inches. Not too bad, not too hard.